Okay, we're back. So we are on Unit 7, Day 1 notes about the Pythagorean theorem, and I was on problem 5. Sorry, the bell. So we're trying to find the length of line segment AB. So we plotted the points, and what we've always done in the past is draw in this vertical and horizontal segment, and then count. So there's 1, 2, 3, 4, 5, 6, 7, 8 units going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, going back and forth. And we found the distance. So the distance formula, we always did the square root of 8 squared plus 10 squared. And, we would get 64 plus 100, square root of 164. But what shape is this? Isn't this a right triangle? So can't we do the Pythagorean theorem? Can't we do 8 squared plus 10 squared is going to equal our hypotenuse squared? Oh, same numbers. Wow, that's kind of weird. Ah, same numbers. Oh, same numbers. At the end when we take our square root. So this just is proving the distance formula is the Pythagorean theorem. So that's what I actually taught a long time ago. If you look back in those notes when I introduced distance formula, I did talk about the Pythagorean theorem way back then. So even plotting points and finding their distance, you're making a right triangle. You're just using the Pythagorean theorem. So it's very useful in life. All right, so kind of switching gears, a little bit of a different topic here is since A and B are both the legs of the right triangle, and they're interchangeable. It doesn't matter. Remember, I've been saying the only thing that's important is the hypotenuse. We are going to give the segments, the side A and B, specific names, but it's all going to be based off one of the acute angles as a reference. Never the right angle. It's always going to be based off of one of these other two acute angles. And the problem will tell you what angle to look at. Sometimes there'll be a marking inside. So for this, I have a marking right here, so I am focusing on angle A. So the hypotenuse is still the longest side. It's still across from the right angle. But this side over here, side CB, is going to be called opposite angle A. If you think about angle A, has these two sides. Actually, I'm going to highlight them. This might help you. If you highlight the two sides of the angle, the one that is not highlighted is always going to be the opposite. Opposite goes across from it. So then that leaves the two highlighted sides. One of them is always going to be the hypotenuse, the longer one. The other one we're going to call the adjacent side. Remember, adjacent means next to. It's next to the angle, but it's not the hypotenuse. So we're just going to get in the habit of labeling opposite, adjacent, hypotenuse. And after a while, we're going to get a little lazy, and we're just going to label them H, O, and A. All right, so this is extremely important. The rest of the unit depends on your skill of being able to identify which side's the hypotenuse, which side's opposite, and which side's adjacent a given angle. The angle that you're going to be told to look at. That is huge. So for examples 1 and 2, label the sides opposite, O, adjacent, A, and hypotenuse, H, using angle A as the reference. So every time you might want to start off just by highlighting the two sides of your angle. The one that is not highlighted is always going to be the opposite. Then you just have to figure out which one's your hypotenuse. And again, it's always across from the right angle. And then kind of by default, adjacent is your other side. Every time it's the same. Find angle A. Let's highlight the two sides of angle A. The side that is not highlighted is opposite. Then the hypotenuse is across from the right angle. It's the longest one, and then the adjacent's the other one. Easy peasy, lemon squeezy, but the most important skill in this entire unit. All right, problem 3, fill in the blank with the side. So here we have a right triangle. All right, I want to know what side is opposite angle A. All right, so angle A, I'm going to do this in my yellow highlighter. Opposite is over here. So it's line segment CB, BC, I don't care which two letters. adjacent to angle A. Well, I know that one's my hypotenuse. Well, let me label these. And so this one's my adjacent, which is line segment AB. I don't care if you call it line segment AB or BA. Oh, now this wants us to switch angles. All right, so you might need a different color now, because now it's going to be confusing. So I guess I'll use my red. Now I'm looking at angle C. All right, so now I kind of have to make my brain look at angle C. So now I'm focusing in on the two red sides. So now for angle C, AB is my opposite side. And adjacent to angle C, that's still my hypotenuse. The hypotenuse never changes. But now my adjacent for angle C is line segment CB. And it says, what do you notice? I'm seeing we got the same answer, but for like different things. So, what's going on? What's up with that? So that is then telling me something really important about these angles here. It looks like the opposite of angle A equals the adjacent of angle C. And it looks like the opposite of angle C equals the adjacent to angle A. Now remember, isn't there a special relationship between angles A and angle C? They always add up to 90. They're complementary. Oh, my red pen I think is 9. Angle A and angle C are complementary. These little facts here are going to become hugely important in day 2's notes. All right, so that's it for day 1. Have a great day, and look for trigonometry out in real life. Look for right triangles are everywhere. All right, bye.